Recording in progress.
Okay. Yes. I told you one thing that in the groups the similarity is on the base of valence shell, the number of electrons.
The valency of electrons.
Yes, number of electrons in the valence shell.
Yeah.
Okay, valence shell is what? The outermost shell, the last shell of any atom, any element.
Yeah.
Okay.
Yes.
For example, I told you we draw for the lithium and sodium. Let me open the one note.
Mm.
And yeah, over here we draw for lithium and sodium. You see how many electrons are there in total in lithium? How many in total electrons are there in lithium?
In lithium,
Lithium. How we know about this? By
like the
hmm. We have three things: number of protons, number
yeah
of
7 -
electrons.
3, 7 - 3.
No, that
So
is number of
4.
neutrons. That is number of neutrons.
Oh, okay. So the downside is the thing 3.
Yes, it is in the neutral atom. I told you the number of protons is always equal to the number of
Electrons.
electrons. Okay, that is why. So you see how many number of protons are there in lithium?
Yeah, 3.
Three. That is why there will be three electrons in the lithium. Okay, this is the way we check how many electrons will be there in any species. So you see we have three
Yeah.
electrons. So I draw this image, this the shells, and in those shells I put the electrons. So I told you in the first shell, what is the capacity of the first shell? How many electrons can be in the first shell?
2.
Two electrons. So I filled it with two electrons, right? And how many electrons are left now
1.
for
So you
lithium?
fill it.
We need to fill
1.
three, so we just filled two. Okay. Now one is left, so that is why the one will be filled in the next shell. Okay, in the L shell. Although the
Yes.
capacity of the L shell is to fill eight electrons, but we just have one electron, so that is why we will just fill it with one. Clear?
Mm.
The capacity is of eight electrons. So in this case,
Yeah.
over here you see the sodium. How many electrons are there in sodium? See from here.
Uh,
Electrons.
uh, electrons 11.
11. Okay. So we need to fill 11 electrons in different shells, right? So in the first shell, there
Yeah.
are two electrons, and this shell is known as K shell. In the K shell, the maximum capacity of the K shell is that it can fill two electrons. And then the next shell, the second shell is known as L shell, and the capacity of L shell is that it can fill eight electrons, right? It can fill eight electrons.
Yeah, 8.
So total, how many total electrons are now there by adding K and L shell electrons? How many electrons we have filled? 10.
By adding these two, it would be 8. It would be 10.
It would be 10. K in the K shell there are two electrons, in the L shell there are eight electrons. So there will be 10 electrons. Now one electron is left, right? Because we are saying that sodium needs 11. Sodium has 11 electrons. So for that one electron, we will draw the next shell. Okay. Why can't we put this electron in L shell? And why there is need to?
Because
Hmm.
L shell only has 8 electrons.
Yeah, it has the capacity to fill only eight electrons. It cannot fill
Yeah.
more than eight. So when there is
Mhm.
more electrons left behind, so we will in that cell you will put the electrons. Here you will put the electrons. So you see in both the sodium and lithium, what is common thing? That
Sodium and
in
lithium.
both the outermost shell have only one electron, right? The outermost shell
Yeah.
have just
One
one
electron.
electron. So this is what we say that group 1, these two belong to group 1. Okay, these two belong to
Group 1.
group 1. So we say that lithium and sodium, lithium is 3 and 7, 11 and 23. They belong to group number 1. What does it mean? That they both have one electron in their valence shell. Okay,
Yeah.
are you clear with this? We are not
Yes.
talking about the whole system. We have categorized on the basis of which thing is common in them, right? I told you how groups are formed. How groups are formed on the basis of some similarities. So the similarity in these two is that the outermost shell have one electron. Okay, so that is
Yeah.
why they both belong to group number 1. Now we can see the potassium. Okay, potassium is 19/39. Now let me fill it. We have potassium. That is 19 and 39. Okay, now there are 19. How many electrons are there now in the potassium?
In the potassium, there is 19.
Hmm?
19.
19 electrons, right? So let me draw this. Okay, this is the for the potassium. In the center we have the nucleus. Okay, in the nucleus, what are the things which reside in the nucleus?
Nucleus?
Hmm.
The two electrons.
The
Two electrons.
in the nucleus we have neutrons and protons. Okay,
Protons.
there are always neutrons and protons in the nucleus. Okay, now and electrons reside in these shells. The first shell, in the first shell, how many electrons can be there?
Two.
Maximum capacity of first shell is
Two.
2. So it can fill with 2 shells. The first shell is K shell and it can fill with the 2 electrons. Okay, K shell, 2 electrons. Then this is second shell. How many electrons can be there in second shell? What is the
8.
capacity? 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 electrons. L shell,
L 12.
yeah, it can fill with 8 electrons. Then what is the capacity of next shell?
1.
Sorry, I can't hear you. The M
12 or
shell.
1.
The next shell is M shell, okay? And
Yeah.
the capacity of M shell is that it can fill 18 electrons. Now you
Yeah.
see how many electrons are left behind. If you see this, we have 19 electrons, okay? In this, we have 19 electrons in potassium. So you need to fill 19 electrons. How many electrons are filled now?
10.
10. So how many are left?
9.
9 are left. So can 9 electrons be filled in the third shell or not? What is the
Yes.
capacity of the third shell?
18.
18. So yes, we can fill 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this I should draw some in the other way so that it can be filled. Now this is M shell. Okay, in the M shell we have filled 9 electrons. So in total now you have 19 electrons. So this is the diagram of the potassium, but we cannot, you know, in the potassium you cannot have such a thing like this. There is 2 into 8 into 10. and there will be maximum residing capacity will be, you know the concept of what we can say, the subshells.
No.
Actually we don't have such shells. I will explain you. First you tell me what do you know about this?
Subshells, I don't know.
Hmm. How we can say that there is uh, on this, okay, let me erase this one. This cannot be in this. This will be 8 electrons, okay, and there will be one more shell, okay, one more shell. I will explain you this, how is this happening. The last shell be the last electron will be in this shell, okay. The maximum capacity of this is that it can fill with 8 electrons, okay, it can fill with 8 electrons. How there will be total 18? I will explain how it can have total 18. Now this shell is known as N shell. This is N shell. So one electron is in this shell. Now what I am saying is that total we have, firstly we have, what is the first shell? K shell, right?
Yeah.
K shell. Then we have M shell. Then L shell, and then M, and then N, right?
Yeah. Yes.
K, L, M, N. These are the shells. M shell and N shell. When we say that the maximum capacity of M shell is 18, okay, we say that its maximum capacity is that it can fill with 18 electrons. It means in
Yes.
this M shell you have K and L shell. That is why it has the capacity of the this one. Are you getting this? That you are
Yes.
adding all the previous shells. Clear? You are adding all the
Yes.
previous shells. Let me explain it to you in terms of electrons. In the K shell you have 2 electrons, right? Then in the L shell, how L shell will be formed? Firstly, the 2 electrons of this K shell, right, plus 6 electrons of this L shell. Then M shell, how M shell will be formed? You will have similar to this, 2 electrons first, then 6 electrons. And in the N shell there will be 1 electron, okay. How is this happening? This is happening on the basis of subshells. In the shells there are smaller shells as well, okay. In the shells there are smaller shells as well. So in this, if you see, there is only, in the K shell you just have S shell, okay. In the L you have S and P subshell. So in the S always there will be 2 electrons, and in the P there will be 6 electrons. This is the maximum capacity of P. So over here
Yes.
in the M you have S and P, similarly 2 into 6, and in the N you have S electron, okay, because it belongs to group 1. So you see this, these three, this one, the potassium, the lithium, the sodium, all these three have 1 electron in their valence shell, right? 1 electron in their valence shell. I will explain you this concept in the upcoming lecture of the electronic configuration. It will be clear to you by then when we will do electronic configuration. Till now my purpose is just to show you how the groups are formed. So these three, if you see, these three have 1 electron in their valence shell. So this is the common thing in all these three. Okay, so we say that the group 1 if we talk about the group 1 elements, what we say that in the group 1 elements, the valence shell of the group 1 elements will have 1 electron, right?
Yeah.
And if we talk about the group 2 elements, what we will say, how many electrons will be there in the valence shell?
Group 2.
2 electrons.
2.
Yes. What about the group 3rd?
3.
Yeah. In its valence shell there will be 3 electrons. In group 4 elements, the valence shell will have how many electrons?
4.
Will be there? 4 electrons, right? And what's next in the fifth, in the group number 5?
It would be 5th.
5 electrons, right? Then in the group 6,
6.
Yes, 6 electrons in the valence shell. Group 7,
7.
7 electrons. And group 8, there will be 8 electrons. And that is why they are known as the stable one. Okay, they are known as the stable one because all the electrons in them are filled. The maximum capacity is of 8 electrons and they are filled. Each shell's maximum capacity is of 8 electrons, just like I show you this one. This 2 plus 6, 8. 2 plus 6, 8. Right? So
Yes.
this is the maximum capacity. Okay. Now, okay. Yeah. Okay. Okay. Now we will see. Now you are clear with the groups. How groups are formed.
Yes.
Okay. Now next is about the periods. How many periods are there in the periodic table? If you see, we have 7 periods over here. You see this 1, 2, 3, 4, 5, 6, and 7. How periods are formed? They are formed from the left to right. This is from left to right.
Right.
Okay, left to right. So in the period 1, there is hydrogen and helium. In the period 2, you go from lithium to neon. Okay, you go from lithium to neon. Group 3 start from sodium and it ends at argon. Right?
Yeah.
Clear?
Yes.
Are you clear with this?
Yes. Yes.
Okay, now group 4, you will have these two, right? And you will skip these one because these are transition metals. Then we will start from here. Okay, so from left to right, this is 4th period. And we are just ignoring these because these are transition metal, otherwise we will consider them. Then this is group 5th, group 6, group 7. So we have the period, sorry, these are periods. Period number 1, period number 2, 3, 4, 5, 6 and 7. Clear?
Yes.
Okay. Now they have mentioned that the column and the row, gives us lots of clues about an element. For example, look at the column number 1, 2, 3 up to so on. The elements in each of them form group with similar properties, right? They have
Yes.
similar properties. Similarly, the rows numbered 1 to 7 are periods. The rows are periods. Period 1
Yeah.
has just two elements. What are those? The hydrogen and helium, right?
Yeah.
The hydrogen and, if you see
Helium.
this one, hydrogen and helium. Look at the zigzag line. This I told you yesterday. What is this? The zigzag line. What is this doing? This zigzag red line.
With non-metals and metals.
Yeah, it is separating metals from non-metals. On the right
Yes.
side, these are, what are these? What are
Metals.
these all?
Metals.
Are these metals or non-metals?
No, non-metals.
Yeah,
Non-metals.
these are non-metals. On the left side, these all are metals. So metals are in abundance. There are many metals on the earth crust, naturally occurring metals, and that's why we use metals in different industries for different purposes. Okay. Yeah, then the next thing, this is very important concept of the compound and the mixtures. Whenever, remember this thing, that when you have a compound, there will be bonding. Okay, compound always form when elements bond together. Okay, when different elements bond together. For example, you have hydrogen and you have oxygen. They combine. They are bonding actually. So this is known as a compound, right?
Yes.
But if you add sand in it, can sand form bond with water? Is it possible for sand to make bond with water?
No. Yeah.
Can sand make bond? Think about it. When you add
No,
sand
it
in the water, what happens?
can't.
Hmm?
You can't.
Your voice is, I think I can't hear you properly. Your voice is.
You can't.
Yes. sand cannot form bond with water. So this is just a mixture. Okay, when you have two or three things added, but they cannot bond together, then you can say that particular thing is a mixture. Clear? That particular thing is a mixture when they cannot bond. So firstly, a compound is made. What I have mentioned, that a compound is formed when atoms of different elements bonded together. Clear? Atoms of different elements bonded together. Then how a mixture will be formed? A mixture contains different elements or compounds that are not bonded together. Okay, you see, elements will be there but they are not bonded together, or maybe there will be compounds, they are not bonded together. Like for example, compound number 1 is water and you have added sand in it. They are not miscible, they cannot dissolve. So this is what this will be known as a mixture. Are you clear with this difference?
Yes,
Are you
yes,
clear with it? Can you now tell
yes.
me in this image which one is compound and which one is mixture?
A is compound and B is mixture.
Yeah, B is the mixture of water and carbon. How we can differentiate? Because you see, carbon is settled down. Okay, carbon is, some of the carbon is present on the top and some carbon is settled down. So this is known as mixture. When you have non-uniform solution. Okay, this is a non-uniform solution. So this is a mixture. They are not bonded. And if you see the A in this, you have a clear solution. Okay, you have a clear solution, and this is water. How water is formed? You know that water is formed by bonding of oxygen with hydrogen, right? So this is a compound. Are you clear till this?
Yes.
Okay. Then we have next thing. What is an atom and what is an element? What's that? What is the difference between atom and element?
Atom element is what's called
Please
like two
speak
things.
loudly. I can't hear you.
Elements are like two atoms combined.
When the similar type of atoms combine. Firstly, tell me about atom. What is atom?
At atom is like something that's like a small particle that makes us matter.
No, yeah, that is also right. But what is this? Atom is the smallest particle that,
Makes us a matter. Makes us.
yes, we cannot break down further by any chemical means. So it means atom is the
Yes.
smallest particle.
Yeah.
Then how elements are formed from the atoms?
Elements are like formed because what's it called like a one type of atom gets together and then the atom makes an element.
Hmm. When similar type of atom will
Yes.
combine, they will form element. Okay. When similar type
Yes.
of atoms combine, they form an element. Okay.
Yes.
It is written over here, an element contains only one kind of atom. Clear?
Yes.
Okay. Now we have, yeah, how many elements occur naturally?
Like 94.
Yes, 94 occur naturally, and rest of the others are synthesized. What is a periodic table?
Periodic table is something that differentiates between different atoms, compounds, and elements.
Now, you can simply say the periodic table. It gives us information about the elements. Okay, and uh, in the periodic table, all the elements are arranged in the order of their increasing atomic number. Simply, at this stage, you can say that the periodic table gives us information about the elements, how they are arranged. Okay, simple. The periodic table
Oh,
gives us information about the elements, how the elements are arranged. Clear?
yes. Yeah.
Okay, give name and symbol of 3 elements in group 1. Okay, now group 1, name and symbol of 3. This is group 1. Can you name and can you tell me the symbol?
Li, Na,
Lithium, lithium
lithium,
Li,
sodium, and potassium.
sodium and potassium. Okay, and these are very important. We will see in the future videos as well. Okay, which element in the periodic table has this symbol? Which element in the periodic table has this symbol? Hint, look into page number
M,
213. What is this?
calcium,
Yes. What's B?
magnesium,
What's N?
nitrogen.
Yeah, nitrogen. Which elements are there more of metals or non-metals? Which are more? Non-metals are more or metals are more?
Metals.
Yes, metals are more. From the periodic table, name 3 metals and 3 non-metals. Okay, tell any 3 metals or any 3 non-metals.
Okay, 3 metals are like iron, lithium, sodium.
Iron,
Iron, lithium, sodium.
iron, lithium, sodium. Okay, non-metals.
Non-metals are boron, carbon, nitrogen.
Yeah, boron, carbon, nitrogen. You said iron in the first, right? Hydrogen, we don't
Yeah.
consider hydrogen. There is a separate discussion on hydrogen. If you said iron, then that's correct. Iron is a
Yeah, I said iron. Yeah, I said
okay.
iron.
Okay, that you expect to behave in similar way. Now they have mentioned. Okay, they have mentioned from the periodic table name 3 metals and 3 non-metals that you expect to behave in a similar way. Now you need to tell 3 metals which will behave in a similar way and 3 non-metals which will behave in a similar way. So what can be those?
I'm not sure.
No, in the similar way you see these will have some similarity, isn't it? The lithium, sodium and potassium, because they belong to group 1. Similarly beryllium, magnesium, calcium. They are saying that don't pick random elements. Don't pick elements randomly. Okay, pick in an order. Just like if we go from this is group 1. Okay, so what is the similarity in them? They all have 1 electron in their valence shell, right?
Yes.
So you can pick from group 1 or from group 2 or from group 3, group 4, group 5. Any 3 from group 1 or group 2. Don't mix them. This is what they are saying. So pick any metals from any group which have any 3 metals which have same properties, same trends.
Okay, so sodium, lithium, and potassium.
Yeah, lithium, sodium and potassium. Lithium, sodium and potassium. Okay, then non-metals.
Helium, neon, argon.
Helium, neon, argon. Yeah, okay. Then we have water is not an element. Explain why. Yeah, why? Photo is needed. Water is not an element. Think about it. I have drawn the image as well. I have drawn the diagram for this, not the image.
Yeah, because you need 2 atoms of hydrogen.
Yeah, it has atoms of hydrogen and
Oxygen.
oxygen. So it has different atoms. We say that you will simply explain an element is formed from just one kind of atoms. But in water, you have hydrogen atoms as well as
Oxygen.
atoms. That is why this is not considered as an element, but it is considered as
Element.
a compound or mixture.
Wait, compound.
Yeah, this is a compound. Okay, define a compound and mixture. What is the difference between compound and mixture?
Compound is like 2 or different elements that are bonded or like are together.
Hmm.
And mixture is something like 2 or more substances that are mixed together.
Sorry.
Mixture is like 2 or more substances that are mixed together.
Not the yeah, that is a simple definition. But according to this, what we will say that elements will be combined, but they are not bonded. You are just mixing the elements. 2 or more elements or 2 or more compounds, not just simple substances. because in substances there can be many different things. Okay, so when you are particularly talking about something in chemistry, we need to use the appropriate terminologies for that. So for example, if we talk about the mixture, we say that a mixture will have different elements in it and it will have different compounds in it, but those compounds or elements will not be bonded. On the other hand, when we talk about the compound, we say that compound is made up of different elements. Okay, it is made up of different elements that are bonded together. Clear? Are you clear with this?
Yes.
Okay. Now we have more about the atoms. We see that protons, neutrons and electrons. As I told you earlier, that the atom, when we talk about any atom, so we say that firstly we talk about the matter, and we say that matter is anything which have mass and it occupies some space. So how matter is formed? Matter has 4 states: solid, liquid, gas and plasma. But when we talk about the composition of matter, any matter like the solid or gas or liquid or plasma, what is the composition of that matter? At atomic level, at microscopic level, we say that everything is made up of atoms, right? And within an atom there are some subatomic particles as well. Are you clear with this? I am saying that there is matter firstly, and matter can be solid, liquid or gas, right? And they are made up of atoms. And when we go further, the atoms have some subatomic particles in them. Clear? Are you clear with this? Okay. Now, what are the subatomic particles? There are actually many, but at your stage they have just mentioned the 3. These are protons, neutrons and electrons. In the higher classes you will study that there are mesons, there are positrons, there are many subatomic particles. But now we just need to focus on these 3. So how these 3 subatomic particles are arranged in an atom? In the nucleus, you see this nucleus, we have protons in the nucleus as well as we have neutrons in the nucleus. Okay, they will be clustered together. There is a cluster together. They are clustered, and this is a very heavy part of the atom. Okay, just like the nucleus of a human cell, we say that nucleus is the dense part region in the center. It is the denser region in the center. Why? Because in the nucleus you have much more information, and nucleus contains the genetic information, and nucleus control the cell. In a similar way, when we talk about the atoms, we say that the nucleus of the atom is made up of protons and neutrons, right? It have protons and neutrons, and the electrons will be residing in the shells. You see the shells, we have different shells over here like this. These are the shells. So the protons and neutrons, they cluster together in the center and they form the nucleus. This is the heavy part of the atom. Clear? In the center you have nucleus, and in the nucleus you have protons as well as neutrons. Now can you tell me what will be the charge on the nucleus? What will be the charge on the nucleus?
Recording in progress.
Okay.
Yeah, I asked. I got you finished.
Okay. Yes, in the center I was telling you that there are protons and neutrons. So what will be the charge on the nucleus?
Charge on the nucleus. Yes.
Positive charge. Okay, because in the nucleus you have what? You have protons. Protons are positively charged and neutrons are neutral. They don't have any charge. So when you have these two species, so definitely in the nucleus you will have overall positive charge. Okay. And the electrons reside in the shells. The electrons reside in these shells. Okay, so this is the basic thing how the subatomic particles are arranged in an atom. Are you clear with this? They have mentioned that the electrons circle very fast around the nucleus. The electrons circle, they rotate around the nucleus in the shells, okay, in different energy levels. Basically these shells have different energies, that's why we say that they have different energy levels.
Yes.
Okay, now we can read from here. They have mentioned the protons, neutrons and electrons. We cannot break down an atom by chemical mean. Okay, this definition we have discussed in the first lecture of chapter number 2, that you cannot break atom by any chemical mean, but in fact an atom is made of even smaller particles. Okay, atom is made up of even smaller particles, the subatomic particles. What are those?
Yes.
The electrons, the protons and neutrons, right? These subatomic particles are very light. These are very light, so their masses must be given in atomic mass unit. Okay, now what they have mentioned is that these subatomic particles like the protons, neutrons and electrons, they are very small in size. So you mentioned there, you cannot say that this proton is 1 kg, its mass is 1 kg, or it is in 2 gram. We cannot use these units because these are very big units. Okay, so what units we can use? We can use atomic mass unit, that we are seeing these proton, neutron and electrons at atomic level. We have these things at atomic level, so we will consider this unit, atomic mass unit. Clear? Are you clear with this? That why we consider atomic mass unit?
So, what's it called? Like the masses should be given an atomic mass unit instead of grams.
Yeah, when we talk about, we say that the protons, neutrons and electrons, they are very small, so you cannot use kilogram or 2 gram in that. You can only use atomic mass unit because these are smaller quantities, right? These are very small and
Small.
you can only weigh them in atomic mass unit. So when we weigh them in atomic mass unit, we say that proton has a mass unit of 1. Proton is considered as 1. Neutron